Yeah, hi everyone. My name is Sebastian. I'm CEO at metaphacts. And what I want to talk to you about today is our solution for enterprise information architecture. And maybe just a quick check. Who of you has heard of enterprise information architecture? A few, that's not too bad. So we're going to walk through the basics a little bit to give you some background on why we think this is something important to know about and why knowledge graphs and AI are an amazing fit to support this. So just quickly on metaphacts, we started out in 2014. We are based in Walldorf, Germany. There's this other smaller software company based in that same town, not affiliated with them. We have one software product, which is called Metafactory, which is a knowledge graph platform. And we have, over those last 10 to 11 years, utilized that to enable people to more efficiently and easier get access and work with and build knowledge graphs. So there are things in there from vocabulary to ontology modeling, specifically focusing on business users and domain experts, all the way to searching, visualizing, exploring knowledge graphs without having to know knowledge graphs in detail. And what we have done fairly recent, I would say over the last 2-3 years maybe, is we have seen a pattern emerging again and again, where customers had a very specific need, and we have built solutions in our platform for them over and over again, looking very familiar. So we thought, well, why not package that up as one solution and bring that to you ready-made? And what we are addressing with that is the typical customer scenario of trying to understand how is my organization actually working and how are changes affecting my organization. And changes means changes on the business side, like we're changing a process or we're introducing a new location or addressing a new market, all the way to understanding how IT changes are maybe affecting those business processes and how the organization works. And what we have seen over and over again, that the biggest challenge in that is that we have IT and business who have to work together on that and don't really understanding each other. The terminology they use, how they talk about things, how they think about it, is just entirely different. And there is a lot of effort on trying to bring that together. There's the whole idea of data governance, and we have seen many efforts in various different disciplines and various different systems to kind of get hold of that, to get an understanding of the complete IT landscape, of the impacts on the business, on where specific IT assets are utilized. But what we have seen is that all of those efforts, being it business glossaries, data catalogs, they all kind of created little silos again, because there is barely any bridging or interaction or connection between those. So what that means is, for most of those questions, I'm still left to go to different systems. And depending on where I sit in business or IT, I very likely don't have access to all the systems I actually need to be able to answer such a question. So this becomes a very complex interdisciplinary task across many systems, bringing all of that together. And I'm not even talking about the actual data in the business systems yet. I'm just talking about where is that data actually. I want to know information about our current customer development in the European market. And I want to understand which IT systems we are utilizing for that, and if there are things that we could apply in other markets as well, in how we run that process of customer acquisition and which IT systems we use in that process. And it's barely possible to get all of that together. So the one thing is all of those different silos. The other thing is the typical thing we address with knowledge graphs. We have data, or in that case, mostly metadata in those systems, but we have to up-level that. We have to get that to information, to knowledge, to then being able to drive decisions from that. So we need context, we need meaning, we need insights to really utilize that in the right way. In short, we need a semantic model. We need somewhere where we define all of that and bring those different assets together. So the approach we are taking with enterprise information architecture is we want to take all of those different silos that you have in your organization, all of those different data governance systems, all of that metadata, the knowledge from business to IT, and bring that together into a semantic model. And to take some of the learnings away from that already, it's not just one semantic model. Because if we're looking at the IT aspect of it, or if we're looking at the business aspect of it, or the process aspect of it, these are completely different views. So we have to capture them in their own specific model, and we have to bridge between those models to help people to communicate with each other on those topics. And then we can utilize that to answer those really hard questions. Then we get that complete overview, that seamless integration, that flexible, efficient system that helps everyone in the organization to be more efficient. And what does efficiency mean on that? So some of our customers, for example, saw that they had to, whenever they wanted to change one of their systems, when they wanted to migrate to a different vendor, when they wanted to upgrade it just to the latest version, they were faced with like a 5-6 month discovery project, just trying to understand the ecosystem in which that IT system was living before they even could apply any such changes, because they couldn't understand risk, impact, and so on before that. And if you're running that in-house, it binds a lot of resources. If you're running it external, you are faced with probably $500,000 or more of invest just for that one upgrade that you want to run. So kind of ridiculous expense for something that should be company internally available. So what is that semantic approach we're taking there in short? So we're linking all of those different sources. We unify that via a semantic model. We utilize that semantic model by capturing the language of each of those different groups. And that's not just taxonomies, it's specifically ontologies, schemas describing that in more detail. And through that, we allow them to derive action plans and understanding and derive decisions from that. To govern all of that, we have an overarching enterprise information architecture model. And that's the only screenshot I have today of the platform. For everything further, we have demos at our booth, so you can really dive into the details of that with the different views, including utilizing the AI to interact with it. Because what we have seen is that no matter how simple we make it, there are so many users in the organization that are just one-off users, that are just coming in from time to time to utilize that, and they need a very easy way to use it, which is best to be achieved with a conversational interface, with an AI, where they don't have to know how exactly this works and how exactly to ask questions, but they can just come with the question. And this overarching model is governing the kind of things we are tying together there. Persons, processes, business objects, and so on. And that all comes together in an architecture where we have those existing systems on the left side. We have a data access layer bringing that all together. A little bit more about that in a second. Everything is persisted in a knowledge graph database. All of that is part of and orchestrated by the Metafactory platform. We have that semantic model as the bridging component across everything. And we have that user interface as a combination of APIs, Web UI, and AI. And through that, I can then ask my questions and interact with that system. The semantic data model, I already said, it bridges a number of domains. So at the center of everything is what we call the business object. And the business object is, if you think of the business world, these are the things you would be talking about. A customer or a manufacturing line, an assembly. But it can go very granular. It could be a packaging material. Things that are in different parts of the business relevant, and we capture them in the term in the way that those teams are talking about them. And we are interlinking them because obviously none of those live on their own. So we have relations between those business objects, and then we are tying it to all of the metadata and everything that's important to really understand them. So we are tying it to the IT system, we are tying it to the business process, we are tying it to the employees and the people responsible for it, the power users, the ones interacting with it. So we get a comprehensive understanding of where that business object sits in our organization. And we are tying it to the data product all the way down to the physical layer. And I'm going to talk about that also a little bit more. And that's what's creating that insight in the end. And it is very nice that by having those different areas, we can use that data access layer to pull in information from those systems where it already exists. So you very likely have a business glossary with many of those terms already. We very likely have a data catalog where you already have some kind of data source or data product documentation. You very likely have some process repository or government compliance systems where you are capturing parts of that already. So we don't have to replicate that. We can just pull that in, virtualize or materialize it, and then sit on top of that and draw the connections or help the respective users drawing those connections. So if we look at that model, in the end, it becomes 3 relevant layers. We have on the top, we have that business object layer. And into those business objects, we are tying this logical layer. So the idea of that is creating kind of like a prototype of how we, in an ideal world, would store this. So we are looking at it mostly from a business user view. We're looking at the relevant attributes and relation that should exist for a manufacturing line. So it probably has a maximum throughput. It has connections to the different machines that are associated to it. It probably has standard operating hours in which it is active. So we're capturing that in such a logical model, not yet thinking about how we in reality actually store it in the different systems. And not even thinking about, is that one system that's holding it, or will it be different IT systems where that information will reside? We're just capturing the ideal of how it should be and how the business thinks about it. And then via that logical model, we can tie that down to an actual physical object. So to an actual modeling of the physical reality, of the database schemas, of all of those IT systems and how they represent that data, linking the specific column in a table up to the relevant attribute in our logical model for those business objects. And that's then creating that overall view. Now, whenever we did that with a customer, one of the first things was, wow, this is amazing, because now we can just have those mappings between that executable and we can actually go all the way down to the data. And now I can have this super AI across all of my data, across all of my organization, and everything comes together. In theory, yes. The reality of that is that becomes even more complex because so far we are integrating data governance, metadata systems. Now, if we want to go to the instance data layer, there is nothing technically really keeping us from that. However, the politics associated with that in the organization, negotiating with the different data owners, the reality of those IT systems, being able to access them all the way to regulatory laws, regulations that do not allow us to maybe just transfer that data and access it easily, makes it really hard to go all the way to the instance data layer. We have seen that, at least partially successfully implemented, but we believe even if you never would go to the instance data layer, you're already creating tremendous value just taking care of those layers further up. So why is this a revolution to enterprise architecture or information architecture? Because obviously those functions already exist in organizations today, and organizations somehow operate today. So someone has to be doing that already in some way. And what we see is that a lot of that is happening in UML diagrams and ER diagrams, in wiki confluence pages and all kinds of things. But what's created is it's static diagrams, static documents, versus what we are creating here is a queryable, executable artifact, something that we can actually utilize, that we can search through, that we can utilize like code, like real data, and work with, something that's rich in metadata versus having just random comments of people on those objects. Something we can validate and continuously improve versus something where we basically have no control on accuracy because it's just a document sitting somewhere, and the moment we created it, it's already becoming outdated. We have explicit semantics. So using the semantic knowledge graph, using OWL and SHACL in that, we actually have a way of completely defining how to interpret that and make it a very clear, understandable system, all the way to utilizing that from AI. That is super important. We interconnect with existing systems, so we're not just putting yet another thing in there, which is super important. And we have that fine granular collaboration on that, where different people can come together, where we create an interface, a user experience that doesn't need you to understand IT and business at the same time. And it especially doesn't require you to understand what OWL and SHACL is. It just allows you to model those things and look at those models and just assess with your domain knowledge, where you are specifically, if this is doing the right thing. And through that, we can very effectively ensure that everything has just one identity. We can recommend things to people where they are trying to model something that might have been modeled already. And with that, very effectively avoid duplications. On the data access side, I've already briefly talked about that. There are two obvious ways to do this. We can federate, so we can virtually access this information where it is. And while for instance data, that probably is not so often a great way, in these cases on kind of metadata from those data governance systems, we see this working quite well. But you can then obviously also materialize and you can pull a copy into the graph for those use cases where you need that. Now, I think it was already in the title, and I obviously have to talk about AI. And what we saw is no matter how easy we made that interface, there was still a number of users struggling with it. If you give that to a business user and you say, hey, could you model your business object? And they have never done any data modeling, they have never been faced with such a task before, they will struggle. And we've done business modeling with interior designers. So we've tried it with people who really had no data, no IT background, have never worked with anything like that before. And we managed to get the user interface very, very close to their needs so that they were able to achieve some level of modeling in it. However, utilizing an AI, we can create a conversational interface. We can guide them through that experience with competency questions and step by step align them with the process. So we are building a model while we just walk them through questions and allow them to just contribute their knowledge to that process. And the way we do that is by putting an agentic AI framework on top of that semantic layer. So what it basically is a layer that combines GenAI LLMs with the semantic model in a neural symbolic integration, and through that provides dedicated agents for specific uses. So, for example, a vocabulary mapping agent allowing to do mappings. We are working on agents for mapping between physical and business objects or logical layer. Having that agent that walks you through the schema or ontology modeling experience. And additionally, you can have very nice agents that allow users to explore what's in that system. So I can start with just asking it, what's actually a business object? And get that definition from that overarching ontology. And I can dive into the details of, which business objects are we actually managing in our organization, in my specific department? And then all the way to those questions we saw in the beginning. What happens if we shut down that specific CRM system in that location? Which of our business processes are affected in which way? Which are the responsible people that I would have to contact before I can do that to jointly create a risk assessment? All of those things can be easily answered by an AI from that semantic layer. And the way we see that is we can have such an agent registry with that. So we can have different agents for different users, for different needs, because again, the IT is going to ask quite different questions in quite different language than the business users will. So we have to cater to each of them to make sure also the AI speaks their language and understands what they are asking and taking a view on our semantic layer in the right way. We can have that, very personalized, even down to the individual person if necessary. And then those AI agents can understand that and translate that into generating a query, publishing that information from the layer, so hallucination-free, answering those questions from our graph directly. We utilize the semantic model for that throughout. So you always have that tie back and that trust layer where you know exactly where does this information come from, with all of the provenance being able to really dig down to the individual system. Where does this come from? What kind of information does this stem from? To make sure you're taking the right decision on that. There are a number of different applications and use cases for that. I don't want to go through the details of that, but I just want to give you a little bit of an idea on what you can do with that once you have that in place. So something we've seen in the financial sector a lot is the Digital Operational Resiliency Act. So having to be able to show that you do have all of those things under control. So by building that, you're not only enabling everyone in your organization, but at the same time, you're achieving compliance with a regulation that, for example, in the financial sector, you absolutely have to be compliant with. In the EU, we have the AI Act. So we have to document all of the AI systems, and we have to capture their risk classification, their use profile, the data they connect to. Now, you have not seen AI in that model. However, if I do have my business objects, my business processes, my IT systems, my data products, nothing is stopping me from adding AI as an additional class to that overarching model, tying it in with the relevant things, and asking people to document that as well. So I have an extremely extensible architecture where if new regulations, new needs come up, I can anytime expand that and serve further use cases from that.
Thank you, Sebastian. Any question? Yes.
One question here.
Fabulous presentation. If we could go back to the part where you talk about agents assisting mapping the physical layer to the business object layer, can you please talk about how those agents handle drift or change over time during the CRUD process for the physical objects, be they the values themselves or the metadata?
Honestly, I don't know all of that yet. So the agents we have ready in the product right now are a number of easily personalizable discovery agents. So basically finding, exploring information. We have the one for mappings between vocabulary terms. And we have now a first beta running on the one for helping you to do the modeling. And what we have already seen is for that physical layer is probably going to be a very strong involvement of the user in all of that process. But what the exact thing that's going to be resulting from that, I think that's still something we are testing out, and where we are also looking for feedback for beta users to understand, which aspects of that are important, especially like temporal aspects, other things. How deep do you need them to serve this use case? And what are the core requirements around that?
Thank you.
Thank you again, Sebastian.